welcome to the Avizo Inspect presentation. So Avizo Inspect is a new version of our Avizo application, or a new edition that we are going to release beginning of next year. So here at ASNT, we are announcing the beta version of the product. So the beta version is going to be available to our customers in a couple of weeks from now, and the actual release is going to happen end of January, beginning of February. So it's based on our flagship Avizo application that has been around for over 10 years now. And basically, you start by loading your data. So any kind of 3D data can come inside Avizo. So it can come from CT, micro CT, nano CT, but also from 3D microscopy. If you have dual beam field SEM data, if you have TEM data, anything that is 3D, we can load it up inside Avizo. And the first thing you want to do, you want to be able to visualize your data, not only to look at it, it's a pretty part, but to assert the quality of your acquisition. So are all the parameters of your acquisition optimal to get the nicest quality you can for your part? Because before we are going to run any analysis of the data, it's very important to have a very clean part. You won't get any good data outside of a junk data if you want. So here I loaded a simple part inside, and I just want to show you some of the measurement that we are adding to Avizo Inspect. So this is what we call dimensional metrology, or the ability to do actual distance measurement on your part. So I'm going to switch to our metrology workroom there, and I'm going to select the part I want to work on. So this is my part. And the first thing I'm going to do, I'm going to try to reorient my part. When you do an acquisition, in order to optimize the beam path, you need to tilt your part very often. So in order to do measurement along a given direction, we need to reorient our part. And the first thing we are going to do in order to do this is to define directions for our new orientation. And for doing this, we need to fit geometries. So the first step, I'm going to use our new fitting geometry tool. So for instance, I want to fit cylinders in these holes. So I'm going to select my cylinder fitting tool. I'm going to set some of the parameters that I want to use to fit this particular geometry there. And then I can select a point in this hole, for instance, and then automatically you have a cylinder that is fitted. I can do the same thing on this side, and I'm going to repeat this, for the other cylinders. Just one click, and we are fitting actually the cylinder inside the geometry. So at this point, I would like to speak about you may hear a lot about subvoxel accuracy for measurement in metrology. And this is what we are doing here. It's not because you have a resolution, for instance, of 1 micron, that you will get a 1 micron precision for your measurement. We can go actually lower than this by extracting a very accurate interface between the part and the outside of the part. So you are able to get subvoxel accuracy, precision, when you do your measurement. So let me fit my last cylinder there, just one click again, and we have a perfectly fitted cylinder there. I'm going to fit a line to define an orthogonal direction. So I'm choosing my fitting line tool there. I pick a few points, and my line is going to be fitted there onto my geometry. So next step is to use this fitted geometry to define direction for the orientation of my part. So I'm going to select my local coordinate system tool. I'm going to tell, okay, I want to use my y-axis as the cylinder axis. I want to use my line as my x-axis for my local coordinate system, and just finish. And then automatically my part is going to be reoriented according to the direction. So now I have, if you look at these orthogonal views, we have a perfectly orthogonal direction for my orientation. So next step, now that I realign my part, and I can create as many LCS as you want, next step is actually to do measurement with this. So we can do a simple measurement, such as a distance. So I'm going to go back to my one viewer view, and I want to compute the distance between the center of these two cylinders, or the axis of these two cylinders. So I'm going to go to my measure tab, select there, dimensioning measure, and select distance. And I'm going to tell I want to create, to measure the distance between these two cylinders, create, and automatically I will have my part there with my measurement. So I can measure distances like this, I can measure diameters, radius, angles. We have a bunch of measures that you can apply actually inside this metrology workroom. And what is important is that you want to be able to repeat this measurement on another part. So, you are going to define what we call a test plan on your reference model. Once this is done, you can save this test plan and load another part that you are going to register to your reference model, and we do have a very advanced 3D registration mechanism inside Avizo Inspect, and you will be able to replay your test plan onto this new part. And according to measure nominal values and tolerance, you will be able actually to tell, okay, this measure is okay, it's a range of my tolerances, this measure actually is out of the range of my tolerance, and I want to reject my part. So I'm going to show you a very simple example of this. I'm going to remove what I just created there, remove my fitted geometry. And from this part, I'm going to load the test plans that I saved before. So open test plan, and I'm going to go to my test plan directory, and I'm going to load my test plan there. And automatically, all of the geometries that were fitted actually on my reference model, all of the measurements that were done on my reference model are going to be reapplied. So the geometry are going to be refitted on the model, the measures are going to be made again according to the fitted geometry that has just been refitted on this model, and then you can decide after this, if your measures are in range or out of range compared to your tolerance information. So as you can see there, so I just need to switch to my local coordinate system to make everything orthogonal. And here, so you have an example of replaying a test plan with diameter information, radius information, distance information, and we have some also tolerancing information there. So if I go there, I can show you, for instance, here we were measuring angularity between the two lines that we fitted before, so line and line 2, and this is giving us an angular value, an angle value between the two lines of 0.58 degrees. So this is a test plan, and the way you can automate actually a test plan when you are making measures that have been defined on a reference model. So the second thing I would like to speak about there is that everything you do there, you can load also a report template. This report template is based on HTML, so you have an HTML template, and you can tell Avizo Inspect to take snapshots and associate the snapshot inside a particular location inside the report, but also you may have results from your analysis and associate results, these spreadsheets, directly inside the report. And so you can get something, I'm going to show you a report that was generated there, so in PDF or in HTML. So I'm just loading. So this is an example of a report that has been generated by Avizo Inspect, where you can actually define a template where you have frames, you can have static information inside, such as your logo, for instance, the date, number of run, and then you can associate snapshots. And then we have also, so if I zoom in, you have some result of analysis there that can be shown inside this report. So this is an example of the PDF page that has been generated. Same example, so it can be actually an HTML page. So we are producing HTML or PDF from the result of the inspection. Okay, something that I want to speak about also, so let me start a new version there from scratch. And I'm going to load another part, a very simple one. So in this example, we have multiple data sets. So I have 4 pistons that have been scanned. They are not perfectly registered. So it's just to show you that it's not necessary for the part to be perfectly registered to go through this test plan workflow. So if I go there and I take my first part, go to the metrology workroom, and I'm going to open a test plan on this. A very simple test plan that is going to measure the diameter of the hole there inside. So you can look at it there. So this is the measurement that was done on this first piston. Now what I can do, so you can see the measure 24.1691 millimeter. So I can go there and change actually to my second piston and try to reapply the same test plan. And our cylinder is automatically going to be fitted. You can see we get a different measurement. So you can repeat this kind of measurement on several parts and accept or reject a particular part according to your tolerancing information. Okay, something else I want to show you is the ability to create what we call recipes. And a recipe is a way to automate process not only the measurement, the dimensional metrology I was speaking about, but the ability to actually do some image processing, advanced image processing workflow on your data, and then repeat this recipe on different data sets. So I'm going to take a very simple example there. I'm going to run what we call an auto thresholding that is going according to the calibration to build a mask of my part. And then on this, I'm going to generate a surface. And now that I have my surface that has been generated, I can actually show it to you. So this is actually the 3D surface representing the part. And you can export this to STL. So if you want to perform some additive manufacturing or 3D printing, so we have all of the tools inside Avizo that allows you to do this. So we are able to generate a 3D mesh like this. We have tools to clean up the mesh. If you want to go even further and run some simulation applications, Fluent or ANSYS or Console or Abacus to do stress analysis or flow analysis, we are able to build a 3D mesh from this information and export this to simulation software. But what is important is that I created there a very simple recipe. And I can actually click on my result there and go to create recipe. I'm going to switch to my recipe workroom, and automatically I can replace this recipe. I can set breakpoints if you want to modify some of the parameters of the workflow, and I can run my recipe, and automatically it's going to reconstruct my 3D surface. I don't have to redo all of the steps again. So you can imagine, very complex workflow like this, with possible interactivity inside or totally automated. You can save your recipe, and then you can actually load different types of recipes that you have created using this Avizo Inspect. Okay, so the last thing I would like to show you is, and I'm going to just start a new version, is our ability to create recipes for more advanced processing. And I'm going to do a very simple porosity analysis workflow there. So I'm going to just let the recipe run, and we're going to get actually all of the results automatically from this workflow. So the first table that we're seeing here is computing the distance to the closest neighbor. It may be important when you are computing a pore distribution. So we have all of this information. So pore distribution, so localization of each pore, their volume, their shape also may be important to get. But also how far away is one pore from the closest one? How far away is a pore from the surface of the part? So all this computation, we are able to create a recipe to extract this kind of information. And if I show you the result of this, so this is actually a part that we scan. This is a little camclit. I don't know if you are a sailor, actually, if you are sailing, but this is coming from a sailboat, and we can actually block the line there. So we scan one of the little rotating parts, and actually it's very, very porous. So there is a lot of pores inside, as you can see there. And actually I can show you only the pores. So you can see that, and if I change a little bit my range there, it's going to be more obvious, like this. So here, the color of the pore is showing how far away is the pore from the surface of the object. You may have a 1 cubic millimeter pore that is more than 1 centimeter away from the surface of your part, but you don't care about it because it's too far from the surface. But if it is a few millimeters from the surface of your part, then actually it may be very important, and you can consider this defect very important and just reject the part because it's too close to the surface and it's going to cause some problem when you are going to use the part. So here it is. So this is Avizo Inspect that you can use to automate your inspection workflow. You can use it also, so it's not only for inspecting parts, but you can also use it for material R&D. If you want to look at porous material, at fibrous material, so something I didn't show you, but we have also a lot of fiber analysis tools. It can be individual fibers, it can be bunch of fibers. We are able to get orientation, diameter, length measurement on these fibers, as well as I show you, so all of the porosity analysis workflow.